Hello everyone, this is BronyCalc, and today we're going to be going over the first two problems from the ARML 2017 team round. I haven't done these before fully, but I have looked over them and I do know how to solve them. So without further ado, let's get started. So, first problem, we have A, B, C is an ordered triplet. These are all positive integers, and the square root of A to the B plus C factorial is equal to 28. First off, we're going to get rid of this square root since it just makes things complicated. And we get a to the b plus c factorial is 784. Since this is 784 and this has to be positive, we know that c is somewhere between 1 and 6. Using that, we can check all the cases. So c is 1, then this has to be 783, 784. You can quickly check and see this is not a perfect power, or you can remember that the only perfect powers areas that differ by 1 are 8 and 9, so we know that this has to be 783, 1, 1. Then we have 2 factorial is 2. This is 784 like usual, I don't need to write it down. 782. Now this isn't a perfect power either. You can go through them, you can check all of them if you want, but this is not a perfect power. So we have 782, 1, 2. Next up is 6 and 778. Let's see here. That's not a perfect square because it's too close to 784. The next perfect square is 729, in case you're curious. That's the next lowest one. So we know that we don't have to worry about that yet. So 778. You can also go through cube, fourth, fifth, etc. You're not going to find anything. So 778, 1, 3. Next up, we get 24 and 760. Not a perfect square, not a perfect cube, only 1 0, so it can't be a perfect power of anything. So we get 761, 4. And so far nothing interesting has really happened yet. Just been working with really basic numbers. We can go through, now we move on to 5, we get 120, which means this is 664. The nearest perfect cube is going to be 729 and 512. Perfect fourths, you get 625. A perfect fifths is you get like 243 and 1024. It's not a perfect power. So 6, 6, 4, 1, 5, not 6 yet. This is 6 though. 720, and if we do the math, 64. Now, for 64, we obviously have our 64, 1, 6. But we also have, this is a perfect square. So we have 8, 2, 6. Perfect cube, so 4, 3, 6. And perfect 6 power, so 266. So that appears to be all of them. We can't go any bigger with the factorial. We can't get any lower than that too. So now we can count them up. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is indeed the correct answer. We have found all of them. We can now move on to question number 2. So, we had this guy starting at 0. He makes jumps of 1, 2, 3, 4, 5, 6, 2017. So we know how long the jumps are going to be and what order they're going to be in. But what we don't know is which way they are. We are told that if we're at an even integer, we go forward. If we're at an odd integer, we go backwards. So let's just try some stuff. We start at an even integer. Plus 1, then we go to 1, then Since we're at an odd, we go backwards, -2, -1. We're at an odd again, so -3 takes us to -4. Then we are at an even, so we add 4 to get to 0. We add 4 again. And at this point, you should be able to see a pattern, 5. So we have plus, minus, minus, plus, plus, minus, and it's probably going to be minus again. We can actually show what's happening here, because each odd number you add, positive or negative, changes the parity, which means we change the direction we're going, while each even number we add or subtract keeps the parity the same, so we keep going in the same direction. So now we have this pattern that is actually pretty nice. And while it may not look very nice, we have to somehow sum up all the way up to 2017, but we have to include positives and negatives and all that. What we can do is, for every even number, we can do this. So 1 minus 2, that's -1. And -3 plus 4, that's 1. This is -1. And we can use this to figure out the location at any point. So basically, here we can look at it in terms of parity. Because as we can look at it in terms of, well, not parity quite, but we can look at it mod 4, and we can see that if we're at 4n plus 1, the cycle has reset to 0. So if we're at 4n plus 1, and then we're just going to be adding 4n plus 1. So our value is 4n plus 1. If we're at 4n plus 2, then our value is -1. 4n plus 3, we're going to subtract 4n plus 3 from that, so we get -4n minus 4. And then 4n plus 4, or just 4n, that's going to give 0. It resets to 0 every 4 numbers, which is really nice. So, using this information, we want to sum up where it is for each value from 1 to 2017. Well, 2017 is just 1 plus 4 times 504. So we're going to have 504 groups, and if we sum up each group of 4, we get these cancel, and we get 1 minus 1 is 0, minus 4, so it's -4. So we get -4 times 504 plus 2017. But since we see this here, we know that this is just 1. And with that, we are done. So these were both really fun problems. I didn't end up working on them, but I know my team got both of them right. And yeah, it was cool. Seeing these, never having done them before. Anyways, I hope you liked the video. Be sure, if you did, be sure to leave a like. Send me a comment for anything you think I did wrong, or just if you enjoy, or once again if you enjoyed the video. And maybe check out some of my other videos. I've been doing a bunch of ER problems from this year's ARML competition and some other competitions this year. And subscribe, ring that notification bell if you like what you see. Maybe share it with some of your friends. And I will see you next time.